Okay, today we're going to talk about projectile motion. We've just finished up talking about vectors. Uh, so you have to understand those concepts to be able to understand projectile motion. Now, when something moves, it has projectile motion. Usually it moves in a parabola shape, and it has components. It has horizontal components, like the x components, and vertical components of motion, um, like the y component. All right, so this is a simulation that you're not going to be doing. The lab you're going to do today is not with this simulation, but afterwards I have you using this simulation to kind of play around with it. All right, but if you shoot something, at an angle with a cannon, and I'll put this on slow, and you notice I've got components checked off for the velocity vectors just because I want to see, and you shoot it. If you notice, the horizontal component, is in the x direction, y component's in the y direction. At the height of its motion, it only has a horizontal component. It doesn't have a vertical component. There's no arrow pointing down when it reaches its height. It's right there. And then as it comes down, motion, the velocity vector is pointing down. As long as it's going up, the velocity vector is pointing up. So if I, you know, put this higher, the angle at 50 degrees, and I shoot it, if you notice, you can see the vector's changing throughout the motion. This is called, two-dimensional motion. And you can figure out, it's like what they used to fire catapults back in the old days when they would try to take over a fort or a castle. They would shoot catapults, and they would figure out, they'd use this science here, at a certain angle, and to knock down, fortresses and walls and stuff. But you can play around with the speed on this and change it to see how it's different and everything. But what I want you to use it for is at the end of the lab with the other simulation, I want you to come back to this, and you see this target here. You can move it to different places, and I want you just kind of play around and see if you can figure out the speed and the angle you would need to shoot at to hit that target. I could just play around and see if and if you notice that right there would be short, hit the man. I'm trying to hit the target, so I would have to, increase the speed. You can try to increase the speed until you hit that. And you notice that would be too much. I might need to adjust the angle. But what you can do is just try to hit it at different, after you try it and you hit the target, and then just move it around and play around with it. You can either, that's on the intro, you can select lab, and you can do the same thing. Try to hit the target, or you can select vectors, either one of those, and play around with that after you get through with the lab. Now, what you're going to be doing is you're going to open up the link, and it's going to bring you to this right here, and you're going to be taking some different measurements where you're finding the range and the height at different speeds and different angles. It tells you start off the initial speed. If you notice on the right, you have initial velocity that you can change. You can just drag it and change it to whatever you need to, and you could change the angle too. And you're taking different measurements and answering questions. But what you do is you just hit fire, and it's going to fire one. If you notice, it gives you the time taken, how long it stays in the air, the range. That's the horizontal displacement, and the height, which is the vertical displacement, and it gives you your final velocity. Of course, your initial velocity would be, what it's telling you on here. All right, so you're going to do this for different things, and you can clear it each time and change these things, and fire it again to get new numbers. But and then answer the questions that go along with this.